In this video, we're going to learn about combustion reactions. There's two types, complete and incomplete. We'll learn what they are, and we'll learn how to predict products of combustion reactions. So combustion reactions, that involves taking a fuel, and the fuel is basically something you burn. It's usually a hydrocarbon. And a hydrocarbon is a big compound made up of essentially just CNH. So a bunch of CNH. So CXHY, because this X and Y can vary. So I don't know, there could be C3H8. There could be CH4. There could be C4H10. These actually are very common fuels. This is methane, the stuff you would use to light a fire in a Bunsen burner. This is propane that you would put in a barbecue tank. This is butane that's found in lighters or lighter fluid. And you can have other elements in there too, but the big part of the compound is hydrocarbon, hydrogen and carbon. And so in a combustion reaction, you take that fuel and you burn it. When you burn something, what you're really doing is you're making it react with oxygen that's present in the atmosphere. So you can have complete combustions where you take a fuel and you make it react with enough, or we say sufficient or abundant oxygen. Sufficient or abundant oxygen. And when you do that, you get a complete burn, which is why we call it a complete combustion. And the way you know you have a complete burn is typically the flame for a complete combustion is going to be a blue flame. So if you see blue fire, it means there was a lot of oxygen present, and that oxygen was able to completely burn that fuel, and therefore give you a nice, clean, and complete burn, and you get a blue flame. So this is called a combustion triangle, and to get that boom, that fire, you need the fuel, the oxygen, and also that's going to release some heat, but and you'll see that written out in the equation. So our general equation for a complete combustion reaction is hydrocarbon plus oxygen produces CO2 plus H2O plus energy. So it doesn't matter what your hydrocarbon is, you're always going to get the same products. You're always going to make it react with oxygen, and you're going to get CO2 plus water plus energy. And this is really the heat that you feel, that transfer of energy to you, that's the heat. Okay, so it doesn't matter what the hydrocarbon is, whether it's C3H8, CH4, C4H10, so on and so forth, you're going to get the same set of products in the end. So if I were to say you have CH4 reacting with O2 gas in a complete combustion, you would predict that you get CO2 gas plus H2O gas. Because it's so hot, the energy released evaporates all that water right away, plus energy or heat. And so how do you know if you have sufficient or abundant oxygen? I would tell you in the question. I would say you have a hydrocarbon reacting with sufficient or abundant oxygen, and right away, that's a keyword that you know there's a complete combustion happening. Okay, well, how does it make sense that you can have the same products if you have different reactants? Well, you're dealing with the same set of elements here. So you will have the same products, but things will balance differently. So if I were balancing this reaction here, let's see, I need 2 here to get 4 oxygens. And then I could do, let's see, so that would be also 4 H's, 1 C. Here it's balanced now. So we have 1 C, 1 C. We have 4 oxygens, 4 oxygens. We have 4 H's, 4 H's. Whereas if you had to balance this, it would be a little bit different. I'm going to add plus energy here as well. So we need 4 carbons because there's 4 carbons here. We need 10 H's because there's 10 H's here. And now all we have to balance is our oxygen. So oxygen, we have 8 plus 5, that's 13. 13 oxygens. So that's a bit hard to balance because there's nothing times 2 that will give you 13. So a quick trick you can do is you can do, 13 over 2. Or you can say the decimal form. So 13 divided by 2 is actually 6.5. So you could do this. You could put 6.5 in 1 here, and technically everything is balanced now. But you can't really have a fraction or decimal in your final balance. So what you'd have to do is at the end, just correct that by multiplying everything by 2 to get rid of that 6.5. And so when you do that, you get 2C4H10 plus 13O2 produces 8CO2 plus 10H2O gas. So that's a quick trick. Otherwise, you could have just done trial and error and you would have got your 2, 13, 8, and 10 eventually, and it would have worked just fine. But again, when you have complete combustion, you have a blue fire, and you know that you have sufficient or abundant oxygen. It's always going to make CO2, H2O, and some energy as per your combustion triangle over here. Incomplete combustion. So you're still burning a fuel, but now you don't have a lot of oxygen present. You have what's called insufficient, and I would tell you insufficient amounts of oxygen. And a visual that shows you have that incomplete combustion happening is you have orange flames, and sometimes you also see this black powder or solid that forms called soot, which is not produced in complete combustions, only in incomplete combustions. So what's produced? What's different? Well, the products are the reactants are the same. You have hydrocarbon reacting with oxygen. The only thing is I would tell you it's insufficient oxygen. And regardless of what your hydrocarbon is, you're always going to get the same products of incomplete combustion. You're going to get carbon dioxide and water, just like for the complete combustion. But in addition to that, you're also going to get some dirty incomplete products. You're going to get some carbon monoxide, which is that dangerous gas that you can't smell. It's odorless and is toxic and can kill you. And then some solid carbon, that's soot. And that's that black powder that's produced, plus some energy as well, because you still get energy released in this combustion reaction. So if I were to tell you C4H10 reacts with insufficient oxygen, what are the products? Well, you would put CO2 gas plus H2O gas plus carbon monoxide gas. That's why incomplete combustion is more dangerous, because that carbon monoxide plus carbon solid plus energy. However, if I had said this was a complete combustion with sufficient oxygen, you would have done basically everything the same, except only put H2O and CO2 and not put the CO and C. So it's just remembering there's two additional products, the CO and the C, because they couldn't be completely combined into the CO2 since there was insufficient oxygen. This one's very similar. Here we have C12H22O11 reacting with insufficient oxygen. Okay, and I would tell you again, it's insufficient, or there's not a lot of oxygen. It looks like a hydrocarbon. It's not quite a hydrocarbon, but it's very close to one. It just has the extra over there. That's no big deal. Same idea. We're going to get some CO2 plus some H2O plus some CO plus some C plus some energy. And there we have it. That was an incomplete combustion prediction. You can try the practice problems below. In the next video, we'll take them up, but try them yourself. So in this video, what did we see? We saw that combustion reactions is when you burn a fuel with oxygen. There's two types that exist. There's our complete and incomplete combustion. And you know you have complete if we say there's sufficient oxygen or abundant. And you know you have incomplete if we say there's insufficient oxygen. The beautiful thing about complete combustions is they have a nice blue flame. Their products are easy to predict. You basically just need to put your CO2, your water, and your energy. The only thing that's different is how they balance, because there's different amounts of carbons and H's, of course. Incomplete combustion a little bit is similar. You just don't have enough oxygen. Your flames are orange, and you have a carbon solidus form as well called soot. And these are dangerous because you have carbon monoxide produced in addition to your CO2 and water. But it's just like before, all the products are the same: CO2, water, CO, and C, plus your energy, of course.